Today we're going to learn about function operations. Adding, subtracting, multiplying, and dividing, which you already know how to do, so we're going to do a quick review of those. And then we're going to learn about embedding them in each other, which is called composition of functions. So here we've got two functions, and we're asked to add them. So that just means we're going to add the functions together. We could also add the outputs together, and that would be the same thing. But here they haven't given us a number to put in, so we're just going to add the two functions. We add like terms, so the x and the 3x go together, the rest of them just come down. We get x squared plus 4x minus 1. This second operation we're asked to do is subtracting our functions. So we're just going to put a parentheses around each one with a subtract sign in the middle. We'll distribute our negative into the second parentheses, changing both of the signs. And then we'll add like terms, and we'll get x squared minus 2x plus 1. Now we're going to multiply them. We're going to FOIL because they're both binomials. So x squared times 3x is 3x squared. And then we're going to multiply x squared times negative 1. We'll combine the like terms, and we'll get 3x cubed plus 2x squared minus x. The next one we're asked to do is dividing. And in this case, we can't simplify that. So we're just going to leave it just like it is. Those are the four basic operations. And here's the new one. This is called composition of functions. When you're doing composition of functions, you're taking one function, the output of that one goes into the next function. If you can't do a specific number, then you'll put the whole entire function into the next one. And I'll show you how. It's written g of f of x, and it might be written with two sets of parentheses. I made a little diagram here of how it works. You've got two function machines. If we put the numbers 1, 2, 3, and 4 into the first one, the function, the first one, multiplies everything by 2. So the numbers that come out are now 2, 4, 6, and 8. We put those into the second function. That function adds 1 to them, and so when they come out, they're 3, 5, 7, and 9. So remember that the second function, it says f of g of x. Since g of x would have been inside the innermost parentheses, we would do that one first. And then we'll put the answer into f of x. So if you had f of x was a wolf, g of x was a sheep, and you have it written as f of g of x, g of x is in the innermost parentheses. So you take the sheep, and then you embed it in the equation of the wolf. So it becomes wolf of sheep of x. Here's another one. If you have a bunny that's f of x, and a superhero that's g of x, and you have f of g of x, you take the superhero, you put it into the bunny costume, and now you have a bunny superhero that's turned pink because you ate the superhero. Then, if you had g of f of x, now f of x is first, and so you would take the bunny, he would be eaten by the superhero, and he would turn the superhero gray. Here's one with numbers. You have f of g, and we want 9. So there's two ways to do it. You can put the entire g function into f, or we could just put in 9 into g and then put the answer into f. We're going to put the number 9 into both of them. So I'm going to write my two functions. G of x is going to be first, and then I'm going to put in 9. Now for my f of x function, I can't put in anything yet because I don't know what to put in until I simplify the first one. So I'm just going to leave that blank right now. We'll do blank squared plus 5 blank. And let's figure out what this first one's going to be. So 9 minus 4 is 5. And so the answer to this one is square root of 5. So square root of 5 is going to go in the next one. So we can say f of square root of 5. And square root of 5 squared is just 5. This one we can't simplify. And that's our answer for our composition of functions. All right, here's a story of appendages that don't give us a number to plug in. So we're just going to plug the entire function into the other function. So it says f of g of x. We're going to write f of x with some blanks. So f of x is 1 blank plus 8. Into that function, we're going to put g of x. So g of x is 1x plus 2. Now our 1s are unnecessary. They can be invisible. So what we really have is just x plus 2 plus 8, which is x plus 10. And that's the answer since we don't have a number to plug in. All right, we have 2 more functions, and this time we're going to put in 4. So we've got 2 square root of x, and then we've got x plus 1, and it says g of f, so we're going to do f first. We've got absolute value of -2, and then we're going to do square root of 4. Well, square root of 4 is 2. 2 times -2 is -4. -4 absolute value is 4. So 4 is the first one, where we would say f of 4 is 4. Now we're going to plug that into g of x. So this one's going to go into the function g of x equals x plus 1. So that's 4 plus 1, so that's 5. And that's our answer. All right, so it says g of f of -100. This doesn't work. This is not part of its domain. The square root can't square root negative numbers. So let's try it and see what we get. -2 times the square root of -100. That's going to give us an imaginary number, and then this is not part of what we're evaluating here. So we're going to say x cannot be negative because the square root can't be negative. So this one doesn't work because the square root of negative is an imaginary number. It would be -2 times 10i, which is not what we're doing right here. So we're going to leave that blank. Oh, here's another one. We've got a pizza. So if f of x is the pizza and g of x is the pineapple, then f of g of x means we put the pineapple in the pizza. G of f of x means we put the pizza in the pineapple. We've got x squared minus 4 and x plus 7 as our 2 functions. We're going to put g of x into f of x. So I'm going to write it with the parentheses f of g of x. G of x, this whole thing is going to go in where x is on the other one. So I'm going to write blank plus 7. I'm going to put an x squared minus 4 in there. So we can simplify our like terms and we'll get x squared plus 3. Now we're asked to do it the other way, where we're going to put f of x into g of x. And so I'm going to write g of x with a blank squared minus 4. And I'm going to put inside x plus 7. So since it's x plus 7 squared, I'm going to write it twice. And I'm going to FOIL. So x times x is x squared. X times 7 is 7x. 7 times x is 7x. And 7 times 7 is 49. I'll bring down my minus 4. And I can combine like terms. And I get x squared plus 14x plus 45. And that's my new function.